Plotting is one of my favorite topics. It's the thing that makes everything beautiful. It's the thing that allows you to clearly express what you're trying to prove or show with a given set of data. By the end of this section, you will learn how to create beautiful plots. Let's have a couple of vectors that represent an experiment that we didn't do, but let's say that we did. And let's say that we were measuring the current flowing through a resistor with voltage from 1 to 20. We made 20 measurements for each of the voltage. We measured the current for each of the 20 voltages. To simulate the voltage, I'm going to create a vector. I'm going to generate a vector from 1 to 20. And as you know, if you use the colon operator, you will generate a vector with a step of 1 between each of the numbers in it. Now, we also need to find our currents. To find the current, we need the resistances. So, let's say that we had a resistor that has a resistance of 10 ohms. So we have R equals to 10. And finally, we want to find the current, which is the voltage divided by the resistance. So our current will be equal to the voltage divided by the resistance. At this point, if I run the code, you'll see that we have a vector U, which is from 1 to 20, a vector I with the calculated current for each of these voltages that we theoretically measured, and the resistance is 10. Now, this is data: voltage, resistance, and current. So voltages, actually. All right. Now, we want to plot our data and show that current changes when the voltage changes. In this case, the current is dependable on the voltage. Current is changing when voltage changes. This means that we want to have the voltage on our x-axis and the current on our y-axis. To plot something in Mathlab, we use the plot function. This function takes an extraordinary amount of arguments, and we will take a look at a lot of these arguments. We can start by plotting the current only, so we're only going to give it the I. And we're going to run it. If you use only one set of data for plotting, as we just did, Mathlab will assume that the data that you gave it is dependent on the x-axis, and as you can see, we have the data that we wanted on our y-axis, but on the x-axis we don't have our voltage. Instead, we have numbers from 0 to 20. Actually, as you can see here, we are starting from 1, we're not starting from 0. So when you use only one dataset, it gets plotted against its indexes, against the number of elements in it. If we now want to plot it against the voltage, we have to use a second argument so that we are supplying data for both x and y. Now, I said that for the x we want to have our voltage, so first we need to give it the voltage. As you can see, our first argument is the x values and the second is the y values. If we run it like this now, it should work. There it is. It's still 20 because our voltages are with an increment of 1, but we can easily change this so that I can prove it to you. So we can do it like this with a step of 1/2. So as you can see now, we start from 1 and we end at 10, but we still have 20 values. So let me put it back to this. Now keep in mind that the sizes of the data must be identical. So if you have 20 x's, you need 20 y's. Otherwise, you will either have an extra voltage and no current for that voltage, or vice versa.